Hi guys, in this video I'm going to be talking about functions in TypeScript. So let's just go ahead and jump in here. Let's say I want to declare a new function. So we can start by writing the function keyword, and let's say this function is going to return some data. So we can just call it return some data, and then you can create a function by adding these parentheses after your function name, and then opening up a function body using these curly braces like this. So this is the function body. Everything inside of these curly braces is called the function body. And then this code, whatever code is in here, is what will run when your function runs. So let's just go ahead and return something like an array of 3 numbers, 1, 2, and 3. And so you can imagine maybe this is returning any kind of other data, but for here we can just return a simple array. All right, so now I have this function defined, and I can use the function simply by calling it using its name, and its name is return some data. So we can just type return some data, and then I can invoke the function by putting these parentheses after the function like this. And so this line of code here on line 8 will call the function return some data, which will then run whatever code is in the function body. And then once that code is finished running, or whenever you reach a return statement in the function body, the program will then return back out of that function, and it will return back to where it was called from, which here is line 8. And you might be wondering, what can we do with this returned data, this list of numbers, or how can we get it? Well, the way you can access this returned value, or whatever returned value comes out of a function, is by simply assigning it to some other thing where you call the function. So here we could say result equals return some data. Now just to put this all together, we can then console.log result, and we can run this code, and you can see that we get this array right here, 1, 2, and 3. And if I change this to be something else like a string, you can see now we get a string over here. So this is how you can create a new function, and then you can return some kind of data from the function. All right, so now I want to show you a few other ways we could have defined this function. With TypeScript, you have a few different options or a few different syntaxes available for defining functions. This is probably one of the most common ways that you will see, by using the function keyword and then a name of the function and then defining your function here. However, we could also define a function like this and then assign it to some other name like this, some other name equals function return some data and then return 1, 2, 3. So this is fine, but we can also do the same thing but not have this function here named. Now I would say these, and so then this will be some other name 2, and we can call this one some other name 1. So I would say these two syntaxes are, while they're valid, they're a little bit less common. You probably won't see the syntax like this as much, but what you will see a lot of is the so-called arrow function, which you could define like this. You could say const, I'll just say arrow function equals, and then here we're not going to use the function keyword. Here we're just going to define a function with the open and close parentheses, and this is where we could place arguments to the function, which we'll get onto in a moment. And then we're going to add this arrow, which is basically just an equal sign and then this this caret operator. So we add these two characters, and then together this is referred to as an arrow, hence ES6 arrow functions, which were introduced in ES6. And then we will open up our function body just like before, and then we can return our list of integers or whatever other data we wanted to return. So these are 4 different ways to define a function, and just to demonstrate that they all are equivalent, what we can do is we can just say like functions, and I'm just going to grab all of these functions here. And the first one is return some data, and then we can just say const we can say for const function of functions, we want to say const result equals the output of that function, and then we want to console.log that result. And so let's run this code, and we will see that we get this same array printed out 4 times over here. So these functions are all basically equivalent in what they're doing. And again, I would say that the first syntax is very common. This was especially common in the past before you had the existence of ES6 arrow functions. And then this syntax here is increasingly more common now. And for me personally, this is just the default way that I write functions in TypeScript, because it does have certain cases where you actually would prefer to write functions as an arrow function. And that has to do with this kind of tricky this keyword, which is beyond the scope of what we're talking about here. But suffice it to say, if you use this as the default way of writing functions, then you probably won't run into these edge cases where having not written functions this way, you have issues with this keyword. So I tend to write functions by default using this syntax, but you will come across functions using the function keyword as well. So it's helpful to know about these other syntaxes here. All right, and so since we are using TypeScript, we have the benefit of a lot of type information in this code, even though I haven't actually explicitly typed anything. So if we look at some of these function definitions, and we hover over them, we will see that TypeScript can actually infer that they are returning these arrays of numbers. And in fact, if I hover over this functions list, you can see TypeScript is even able to infer that this list of functions is a list of functions that return lists of numbers. It's able to infer that by inferring the type of all of these functions here, and then figuring out that they are basically the same type of function, and then essentially saying that this list contains those types of functions. So that's really useful. And it means that once we get to this part of the code, when we are running the functions, we actually know that the result is of type array of numbers. So that's pretty cool. And it's especially cool that we didn't have to add any explicit types to this code in order to achieve that. So that's great, but sometimes you actually would want to have an explicit type definition for a function. So how can we do that? Well, we can define a type for a function by using the type keyword, and then we can give our type a name. So we could say like function that returns data. And then the definition of the type for the function will be kind of similar to the actual function definition for an ES6 arrow function. So it would look like this. You would have parentheses to represent any arguments to the function, and then an arrow to represent the return type, and then the return type, which here we could say is a number, an array of numbers, which we can represent like this. We could also represent it using this syntax here. Either one is fine. And then we can use this type name here to basically assign specific function definitions to declare them to be of that type. And we can do that just like this. So you can see I've added that type definition to these 3 functions here. And there's actually not a way to do this for a regular function definition like this, at least if there is a syntax to do that. I'm not sure what it is. But you can do that with these other definitions here. And that means if I was to change this original definition to, let's say, type array of strings, I would then have these compilation errors in these 3 definitions here, saying that the return type array of numbers is not assignable to type array of strings. So that's pretty useful. This is really doing exactly what we would expect and what we would want it to do. And sometimes it can be useful to have explicit type definitions like this for certain functions in your code. In other cases, it can be useful to not have an explicit type definition and just have full type inference like we had before. Actually, let me leave that there. And in other cases, it can be helpful to just type the function in place. And this is probably the most common way to do it. And to demonstrate that, let's go ahead and introduce another thing, which is how to pass in arguments to a function. So let's say that instead of returning a list of numbers, we want to have these functions actually accept a list of numbers and an additional number, and then we're going to return a list of numbers. And the idea is that the function itself will, let's say, concatenate the additional number on the list of numbers that it's given. And I'm just going to clean this up a little bit and reduce the size so we can see all of it. And I'm actually going to, let me just remove this function here and remove this one here. So let's just keep two functions in here to clean up the code we're working with, and we can remove this guy and this guy. And what's it saying here? Okay, so we have to provide some arguments now, right? So I basically said that this function, this type definition for this function now, and we can change this to concat item to list function. This is now expecting arguments. And so the way we can pass arguments to a function is essentially by declaring or defining those arguments within the parentheses of a function. And what does this mean to pass arguments to a function? Well, it means that when we call the function, when we invoke the function, we can pass data to that function. And then when that function is executing, it will have that data that it can then perform some kind of operation on. So this is useful in a variety of circumstances. And so right now, this function definition here needs to have definition of these arguments in it. So to do that, we can just declare these arguments in the parentheses definition of the function by saying list an additional number. All right, and then let's go ahead and use these and implement this function as we might like it to be implemented by saying return list.concat additional number. All right, so that's going to do exactly what we wanted. It's going to take this initial list and it's going to concatenate the additional number here onto that list, and then it's going to return the result of that. And that means that down here, when we are calling these functions in the list, which TypeScript is inferring to be of this type here, and let's go ahead and just apply the same changes here. We need to actually pass in arguments to this function here when we call it. And again, this is very helpful because we wouldn't want to call this function without passing in these arguments, because then you would get some kind of error or some kind of runtime problem with your code. So let's go ahead and define a new list here, which will just be like 1, 2, 3, 4, and 5. And then we can pass that in here, and we can pass in another additional number of, let's say, 25. So that makes the code compile. And now if we run the code, we will see that for both of these functions, we get the same output, 1, 2, 3, 4, 5, and then the number 25. So this is doing just what we want, and it is showing us how we can pass arguments or data to a function, and also how we can describe that list of arguments in our function definition. All right, and now you'll notice that in these two functions, I don't have any type information on the argument definitions themselves. And that's really helpful because you still have typed arguments and they're coming from this function definition here. But maybe you don't have an explicit type definition for the function, so maybe we don't have this. And then you can see TypeScript is complaining and saying that these arguments implicitly have an any type. So in this case, we actually want to go in and we want to annotate these arguments in place and say what kind of type they are. And so we can do that like that. And then if we hover over the function definition, you can see that TypeScript is able to infer what the return type of the function is, even though we didn't declare it directly. We could declare it directly. Whoops. Like this, and that would be equivalent. So this is really just demonstrating several different ways that you can provide type information for functions in TypeScript, and it really depends on your use case, but in general, adding type information that's more explicit like this is very helpful because it conveys more information about what the code is intentionally trying to do and what kind of data should be passed into it. But as you can see, there's many different ways that you can choose to do this, and so it's really up to you in terms of how you want to write your code. And I noticed that this is not spelled correctly, so let's fix that. All right, so far we've seen how to define functions in TypeScript, and then also how those functions convey type information. So now there's another topic I want to briefly touch on, which is the fact that functions are so-called first-class citizens in TypeScript. And again, TypeScript is just a superset of JavaScript, so this is also a true statement in JavaScript. Now, what does this mean, first-class citizens? Well, it's pretty cool. Let me just go ahead and let's just delete all of this code and kind of start over with a blank slate here. Let's say we have some kind of function like add function. And this add function is going to take, let's say, some number. This is going to be a number type. And this is going to return a new function. And the new function, let's say, is going to take two numbers, a and b. And then the result of this function is going to return the result of, let's just call this some base number. And we're going to return the result of adding some base number with a and b. So this is a bit contrived, but it's also concise, and it should demonstrate this point. So if I call add function, or better yet, let's call this get add function. And then here I can say const add function equals get add function. And of course we have to pass in some argument here. So let's pass in 100 for the base, this some base number. So when I call this get add function right here, I'm getting back another function. So this is demonstrating a few things. One, we can return functions from functions. So that's pretty cool. And then two, which we saw just earlier, we can also assign functions to variables. So I'm assigning, at first I'm assigning this entire function to this get add function variable here, and then I'm calling it and getting back another function which I'm assigning to this add function variable here. So that's pretty neat. You can return functions from functions, and you can also assign functions to variables. So this means that functions are extremely flexible pieces of the programming language that you can do a lot of different things with. And if you're curious, you can also pass functions to functions as arguments. So one of the arguments here to any of these functions could actually be another function. Anyway, so let's just see how this is actually working. So now I can say const result equals add function. And now this add function, as TypeScript can figure out, is this one here, which is expecting two numbers. And again, this function, when it gets called, is going to add those two numbers together with whatever base number was provided to the function originally. So I'm going to pass in, let's say, 5 and 10 here, and then we're going to just log out the result, and this should be 115, which it is. So that's pretty cool. And what we can do then is we can say, we could do this a few times, and then let's change result to be defined with let, so we can redefine it below, and let's just pass in some different numbers here. How about 50 and 100, and then how about 500 and 500? So if we run this, you can see we get 3 different numbers here. And this is pretty cool because we're getting back a function here, which we're storing in add function, and then we can use that multiple times, and we get back different results depending on what we pass into it. So this is, again, this is a bit of a contrived example, but it's really just showing you in a short and simple way how flexible it is to declare new functions and then pass around those functions to do different things. And just to illustrate this last point, we could have a third argument. Actually, let's have the third argument in the first function argument list here. So let's say the third argument is optional side effect function, and we want this argument to be optional, and we can declare that by putting a question mark and then the type definition of this argument, which is going to be another function, and I'm going to just define the type of it in place right here in the code. And the type of it is going to be a new function which accepts no parameters and returns type void. So basically this is a function that doesn't do anything. And we could also define, and so now that we've added this argument here, you can see we don't have any type errors and the code still runs, even though we're not passing in this optional side effect function. And that's because it's optional. We don't have to pass it in. And that's indicated by this question mark here. We could alternatively not have the question mark, and now you see we have a type error. But we could actually provide a default argument for this optional side effect function, which we can just indicate by an equal sign and then a function which returns null. And so this is a bit hard to read perhaps, but this first part is the type definition of our optional side effect function. And then this is the default parameter assignment, which is saying that unless this has been passed in, default it to be a function which returns null. All right, and so then what we want to do is we want to, let's say in our final function here, we can say const result equals that, and then we can call this optional side effect function. And let's say we actually want to pass in the result to it. So I'll put result here, and then we can say in our definition of this function, which now let's go ahead and pull this out to a separate type definition. Optional side effect function equals a function which takes some value, which I'll just say is x, and let's just say this is a number because we know it's going to be a number, and it still returns void. So then we can replace this here with optional side effect function, and then we're going to call that function here, and then finally we're going to return our result. All right, so this code should be doing exactly the same thing as before. Let's go ahead and call it and see. It is. Now let's go ahead and add our side effect function here, which we can also type to be of this optional side effect function type like this. And this is going to take our x number parameter. And then let's just say console.log running side effect on result, and the result is x. And then we want to pass in our side effect function right here when we call the get add function in the first place. Okay, so that's a bit of code, and let's go ahead and run it and see what we get as a result. All right, and so now you can see that this log statement is printed out before each of the results are printed out down here. Okay, so again, very contrived piece of code here, but it's showing us how we can pass in functions to other functions, and then we can call those functions within our functions when they're executing. So this is kind of a bit of a mess now. There's a bunch of functions being passed around, and there's functions within functions, but the point is really to illustrate this point at the top here, which is that functions are first-class citizens in TypeScript. And this means that they're extremely flexible and powerful to work with. And they can be really useful in terms of composing code and composing specific behavior in your programs and applications. All right, so I'm going to wrap this video up now. I think that's probably enough for this particular video. And again, here we took a look at functions in TypeScript. We looked at how we can define functions and some of the most common syntaxes that you will see with functions in TypeScript. And then we talked about how you can also add specific type definitions for these functions. And then finally, we looked in depth at this explanation here of how you can pass functions around to other functions, how you can return functions from functions, and how you can assign functions to specific variables. All right, I hope you found this to be useful video, and I hope you learned something. If you like this kind of thing and you want to try to solve some challenges on these same topics, check out the Pairwise curriculum. We have several hundred challenges similar to what I was working on here, which are all interactive code challenges which are intended to help you learn to code. And if you like this video, please hit the like button and subscribe to the channel for more content like this, and I will see you in the next video.